The engineering triumph of the Port of Rotterdam storm barriers, navigating nature's fury, a prelude to the deluge. The Port of Rotterdam, Europe's largest harbour, is a crucial hub for global trade. It connects goods from Asia, the Americas, and various European points. However, its strategic coastal position also exposes it to the threats posed by nature, particularly storm surges and rising sea levels. This vulnerability has necessitated robust engineering solutions to secure the port and its infrastructure. As climate change threatens coastal communities globally, the journey of Rotterdam's storm barriers exemplifies the intersection of natural forces and human innovation. Setting the scene, a hostile environment located along the Maas River, the port operates in a landscape shaped by water, wind, and land. The area has a history of severe flooding caused by North Sea storms. Following devastating floods in the 1950s that resulted in many casualties, the Netherlands embarked on an ambitious flood management strategy. This background set the stage for the development of Rotterdam's storm barriers, addressing new challenges from climate change. Understanding the engineering challenge, the key engineering challenge was creating an effective barrier system, capable of withstanding not just storm-generated waves, but also the immense pressure during high tides or storms. Every design choice required careful assessment of size, materials, and economic viability. The barriers had to let large vessels pass while maintaining normal shipping activities during storms. Thus, the barriers evolved into structures that integrated seamlessly with port operations. The blueprint of protection, designing the barriers, the storm surge barriers, such as the Maaslandkering and the Hartelkering, utilize innovative engineering to achieve their protective goals. The Maaslandkering, completed in 1997, is a remarkable movable barrier that spans 210 meters. It features two rotating doors that close automatically during storm surge warnings. This design minimizes disruption since the barrier remains open during normal operations, closing only when needed. The Hartelkering is a fixed sluice system protecting the Hartel Canal entrance. Unlike the Maaslandkering, it incorporates sluice gates allowing controlled water flow, decreasing pressure during storms. Materials for both barriers were chosen for their durability against the corrosive conditions of the North Sea, using concrete and high-strength steel for their longevity. Key systems and mechanisms. The heart of the barrier's Maaslandkering's effectiveness is driven by its hydraulic and electrical system, which uses sensors to assess environmental conditions for timely closure. Advanced weather monitoring enables quick responses to impending storms. This system is not simply a barrier, it is a data-driven interface. Redundant power sources were incorporated for functionality during severe weather, informed by past storm experiences. Difficulties faced. Mechanisms of compromise. No major engineering project is without challenges. Initially, the Maaslandkering faced reliability issues with automation and mechanics, prompting a thorough review of its design and components. Through iterative testing, the team refined its hydraulic system and software controls for enhanced performance. The Hartelkering also confronted challenges, needing to endure constant hydraulic pressure from storm surges and large vessel traffic. Engineers calculated the forces from vessels to ensure that its structure remained intact. Breakthroughs and innovations. Redefining standards. A notable breakthrough was the use of advanced simulation tools to model hydrodynamic effects under storm conditions. This technology allowed engineers to visualize potential impacts, leading to design enhancements. Collaboration among engineers, construction teams, and environmental scientists fostered innovations in water management. The barriers set a global standard for coastal protection through their operational flexibility and strength. The real-world impact. A legacy of safety. The storm barriers' influence extends beyond flood protection. They provide security for local residents and stakeholders, reducing vulnerability to natural threats. This strong defense has helped Rotterdam maintain its status as a key international trade center amid climate change risks. Investments continue to flow into the region, reflecting confidence in its resilience. The innovative engineering behind these barriers embodies a proactive approach against climate change, offering valuable lessons for similar challenges faced globally. Conclusion. The essence of engineering ingenuity. The storm barriers at the Port of Rotterdam represent how engineering transcends design. It highlights an ongoing interaction between humanity and nature. By addressing challenges from wave pressure to operational integration, engineers navigate complex decisions to create effective solutions. As climate change progresses, the story of Rotterdam underscores the importance of innovation alongside environmental respect. These storm barriers symbolize what can be accomplished through thorough planning and collaboration, guiding communities toward resilience and a sustainable future. While they physically shield against nature's forces, they also exemplify adaptive infrastructure, laying a foundational stone for future engineering projects globally.